Welcome. Here's where we start to get into some territory that we did a little bit with before in Algebra 2, but now we're kind of taking a little bit deeper of a look at this. It's called piecewise practice. These graphs are kind of cool the way they work, and they actually do work in some different business models and things like that, so there is an application. But we're going to take a look at them algebraically, at least here at the start. So, for instance, if you look at our first example here, we're evaluating a function f of x, but it behaves differently depending on what our x value is. If our x value is 4, or less than or equal to that, so 4 or less than, we plug the value in here. If the value of x is greater than 4, 5, 6, 7, so on, we plug it into this value, which gives us some interesting looking graphs, which we'll be taking a look at in a minute. But for right now, I want your complete and total focus to be on this portion of things. And I basically want you to look and say, okay, that's your first question. Which one does it go into? So if x is 10, which one of these two inequalities does it fit into? Well, 10 is greater than 4. So I'm going to plug it into this first one. So I'm going to have 2 times 10 plus 7. You're only using the inequality to tell you which one to plug it into, and you only plug it into one of them based on what the inequality is. And then I find my solution, and I'm done. This could also be written f of 10. Okay? Just basically we're saying the function at 10 would be this. If I were looking at a graph of this and I looked where x equals 10, y would be 27, is basically what I'm doing. Because this whole thing is always set up as f of x equals y. So for instance, if I get to this next one, x is negative 1/3. Which one does it fit? This one. It's less than or equal to 4. So here, f of negative 1/3 is going to be 3 times negative 1/3 minus 1. I'm just taking my value and I'm plugging it in to the expression that it fits with. So 1/3 of 3 would be 1, but it's negative. So negative 1 minus, 1 is negative 2. And that would be my f of negative 1/3. Okay? Let's take a look at one more. Let's do 3, because this always gets interesting. 4, you're like, well, I see 4 in both. Where's the or equals to, though? Right here. So I have to use the function up here at the top for my choice. So 3 times 4 minus 1 would be 12 minus 1, which is 11. And how would I label that? F of 4. My function at the x value that I'm given equals the y value that I would see if I had a graph of this. And we're going to take a look at graphs of these, but that's basically what you're doing on all of them. So when we get down to the next part, evaluate the function for the given value of x. Not only do I have to figure out which one it is within the function, but I have to look at the letter that's out in front to tell me which function I'm even looking at. Okay, so for instance, and this is going to get really odd here for a minute, I'm going to go ahead and I'm going to take each of these just so I kind of have an easy way of telling you which one I'm looking at once we decide which function we're doing each time. So down here, for instance, okay, I see f, so it's going to be this one I'm looking at. Okay, f of 2, which one of my inequalities does it go with? This one, because 2 is greater than 0 if I were to plug it in. You're like, well, I don't know where to plug it in. It just says 2. Right. You don't have anywhere to plug in? The value is just there. It's going to be your answer. Okay, I know, kind of strange, huh? If I look at number 2, it's f again. Negative 4, which one does it fit? The top one, my red one. Well, nowhere to plug the answer in, so it's just 3, and I'm done. Simple as that. So then when we get to the next row, it's like, oh, now it's g, so now it's this function. 7, which one does it fit? The green one, because 7 is greater than 3. So it would be 2 times 7 minus 1. Which would be 13. Okay? The letter tells you which function. The value, using what's underlined here, tells you which expression to plug it into. Okay? Let's do one more here. Let's do 10. h of negative 2. Okay, which one's the negative 2 fit in? Well, here, going with your equal to. So 1/2, plug in my x value. So 1/2 times negative 2 would be negative 1, minus 4 is negative 5. And one moment while we have a doggy panic here. Alright, we're back. Working a little more here on the piecewise, and again, just a reminder before we move on to actually start graphing some of these. If you're only given one function like we were up top, fairly simple. We're just going to take the x value that we're given. This is always going to be my first step, using the inequality to figure out which expression I'm using. And then my second step is always going to be figuring out, once I plug that value in, what the solution is going to be. If I have multiple functions, my first job is going to be to figure out which function it is. Then use the inequalities to figure out which expression. And finally, taking that value and plugging it into my expression. So we're basically just doing substitution. There's just a couple of steps to get there. So what's actually up with graphing these? Okay, so here it is again. You're like, okay, I kind of see where this comes from, where are all the values going to come from. Now again, different teachers are going to tell you different things with this. So you're going to have to just kind of work with me here. Here's how I like to look at it. Again, f of x is just a fancy way of saying y. So I'm going to graph each of these lines, but if you don't usually, you need to be using a pencil in this case, because we're going to be doing some erasing. So here's how this works. My first line, once I get it graphed and I feel confident with it, I'll do colors here so you know what I'm up to. I'm going to be red on my first line. If I were to graph the line 2x minus 1, okay, y-intercept is down here. My slope is up 2 and right 1. Okay? You're like, Harty, why are you making so many dots? Because I want to be really, really accurate, number 1. And number 2, you'll see the method behind my madness here in a minute. Okay, so here's my line. It's basically been dotted out. Notice the restriction. If x is less than or equal to 1. So go to where x is 1, right here. Okay, there's my dot. From this point, and x values less, which are left. This is the only portion of my line that I am going to have for this particular place. Okay? So, connect those, and that's filled in because it's lesson. So, I want the line only from 1 to the left, because that's where it's less than. Anything else that's there is being erased, because for that part of my piecewise function, the other part doesn't exist. So when I look at the other part now, we'll make this one green, 3x plus 1. Okay, so there's my intercept. 3, 1, 1, 2, 3, 1, 1, 2, 3, 1. And I'm kind of watching them like where x is greater than 1, so I don't even need to do this part to the left. So here's 1, not or equal to. So that closed dot needs to be open, and every value to the right would be included. So the line only from 1 to the right. Any other dots that I may have drawn need to go away. And this is my piecewise function. So this could be a business model where like 1 is a break-even point. That would seem kind of strange, wouldn't it? But 1 where something jumps from one speed to another. If you're at less than 1, it's going down. Once you get to here, it starts to move up. But that's how these look. They're going to look strange. It's going to be rare that you're going to see them connected right to each other. There's going to be a gap in there somewhere. Okay? But again, just the other reminder here. If you have your equal to, that's going to be a closed circle. And if you just have less than or greater than, that's going to be an open circle. That's the one other little catch that you need to really pay close attention to when you're doing it. Okay, let's take a look at 14. I'm going to do my color scheme the same way again. Red, we'll do green. Again, let's see if we can figure this out fairly quickly. So red, x is less than or equal to 1. Okay, well, let's start graphing this. It'll be up 1 and over 2, and you're like, not even on 1. Well, let's graph the other way, with it being less than 1. So it'll be down and over, down and over. And some of you may be saying, wait a minute, why are you going down and over? It looks like positive. But remember, I can also do negative over negative, because that's the same as 1/2. So, for the points I want, they need to be less than 1. I want to go left anyway. So I'm going to go left. So down 1 and left 2, down 1 and left 2. Until I run out of space. So you're like, okay, well, how do I do the 1 thing? Well, let's think about it. What's half of 1? 1/2, okay? So I don't want the 2. So at 1, it's going to be at 1/2. It's going to be open or closed? It's going to be open, because I don't have an or equal to under there. So open circle. Off that one goes. So then for my other one, negative x plus 3. Looks like I'm going to be going to the right. So, right one, right one. Just get those dots. Now again, the intercept one I don't want, so I'm starting at 1. So that goes away. I actually have a dot on my x value as 1 this time. And is it going to be open or closed? Closed, because it's the or equal to part. Close that. Put in my arrow. That one's done. So basically all you're doing for this section is you're going to be graphing 2 lines. And then you're just going to erase the part that doesn't apply to your inequality. Nothing that's too bad thus far. So let's take a look at a couple more. Just to play it safe. Whoops. I got a little cute there. Got my wrong sheet up. We don't want ones that are done already. What fun is that? So, alright. Last part working here, we're going to take a look at 15 and 17. Now again, we've changed our value. Now we're looking at the value of 3. Still going to use our colors. And oftentimes, many of you, I would carry around a highlighter. I've always got colored pencils and things in class, so you can kind of do it that way. But still, graph your line, plot your y-intercept. Up 1 over 1. And I notice x is greater than 3, so I'm going to be taking my points to the right, so I'll keep going right. Now I get to where 3 is at, so anything before 3 I erase. My circle on 3 going to be open or closed. Open, so let me erase that even so I can make it open. And connect the dots, because it's greater than. My green line, my y-intercept's at negative 3. And I'm up 1 over 1. Same slope. Again, x is less than or equal to 3. Oops, I made a bunch of dots I didn't need. Down left. Okay, so let's get to 3 here. Everything else I don't need to the right, because this is less than 3. Ooh, or equal to. So solid dot there. Follow it to the left. And we're good. Okay. One last one, 17. Let's move down here to the bottom. So last one, we'll keep our same color scheme. Alright, this time, we get started at 0, so we'll just plain graph these. X is just up 1 and over 1. Oops, I almost did it again. Am I going left or right this time? X is less than or equal to 0. Less than heads to the left. So it should be going down and over. Alright, so anything greater than 0 I don't need on my first one. Since it's or equal to 0, that's going to be a nice big solid dot. Just follow it over. Okay, 2x. What's my y-intercept going to be? 0. Okay, x is greater than 0, so it's going to be an open dot at 0, and up 2 and over 1. So again, greater than 0 means we're going to be heading to the right with our graph. And we're good. Okay? It's like anything else. Remember, graph the lines separately with a pencil. Check your inequality to figure out what part of the line you need, and also if an open or closed dot at the start, and then erase the rest of the parts that you need. The assignment's down at the bottom of your note sheet. Good luck. If you have any questions, let me know.